So next we have Mauro Morales talking about something that I think not enough of us take seriously, immutable infrastructure. Go ahead.
Thanks. Hi everyone, how are you doing? First of all, I just want to say thanks for the invitation. This is a really, really nice setup. I'm liking it here, and everyone has been really nice. It's my first time in Birmingham. I don't know, it's been a good experience so far, but I flew in last night. I'm tired, I'm jet lagged, so please bear with me. Let me introduce myself. My name is Mauro Morales. I'm an open source developer specialist at SpectroCloud. I don't know what that title means, but it says open source at the beginning, and I think that's cool. I hope you do. And I'm part of the Kairos core team. We are 4 people, all of us based in Europe in different locations. Here are my socials in case you don't want to reach out in person here while we're in the conference. You can do it online. But I promise I'm a nice guy, so try to approach while I'm here. So I want to talk about immutable infrastructure. I want to talk about Kairos. But first, I need to talk a little bit about edge computing. And that can mean so many different things to different people. It's not the same edge at a retail store in a big city like New York as in a submarine in the middle of the ocean, right? So there are so many different areas of edge. So I will try to just summarize a few of these things. First of all, why would anyone want to run Kubernetes at the edge? One thing is real-time processing, especially with so many models coming out today and so many useful features from AI and ML. You might not have the right kind of bandwidth to send all the information to a data center and then process everything and send your results back. Instead, you might want to just make it happen right there where the customer is interfacing with your application. Like I just mentioned, it's bandwidth more efficient if you are at the edge. Also, scalability. Sometimes all you need at the edge is to send another node. This can be a Raspberry Pi. This can be a small computer to expand whatever cluster you have at the edge. So that's relatively easy in comparison to having to design a new and different architecture to grow an application. Also, the other reason is that you can have cloud-native apps at the edge. Now, why would anyone want to do that? That sounds a little bit weird. But one of my favorite stories was when I was talking to the guys at the railroads in France. They were telling me that the commitment for their applications comes hardware and software together, and they have to offer support for 20 years. Imagine that. So the thing is that hardware, well, yeah, that might not be changing too much, but software, you want it to change very often, right? So if you have Kubernetes, you can do you can do incremental progress with your application. Despite them having to run for 20 years, you can still have an experience like if you were deploying those applications in a data center. Another example is only your local data is exposed. So when it comes to security, if someone gets a hold of your Kubernetes cluster in a certain location, only this data is going to be stolen or taken instead of the whole data center being affected. The last thing is reliability. Well, if you only have one machine running at the edge and something fails, it's going to, you're screwed, right? But if you have a Kubernetes cluster, you can properly have high availability. But running at the edge also comes with its challenges, of course. One of them is security. It's very easy that someone is going to steal either your machine or parts of your machine. Provisioning can be challenging. Like I said, It's not the same if you have to go to a retail store that is in a big city, you can send an engineer there. But if it's in the middle of the desert or something like that, well, that's a little bit less likely to happen. Same thing for upgrades. Sometimes you just don't have the ability to send someone there, or they don't want to go right into those locations. And finally, network reliability. There are many cases where you simply don't have the same network that you would have in your data center. So these are the big, why am I talking about these things? Because these are the things that drive how we design our operating system, Kairos. So what is Kairos? The way we like to define it, to try to put it in one sentence, is the immutable Linux meta distribution for edge Kubernetes. But that probably gives you more questions than answers, right? So let me try to improve on that a little bit. First of all, Kairos is trying to improve your experience deploying apps at the edge. We want to make it easy so that you can deploy not just your application, but you're deploying the entire stack, the machine, the OS, Kubernetes, and your application. And it's meant also to help simplify day two operations. Like I said, many times you will not have an engineer at the location. So we try to make it easy so that anyone can just, it's almost like just rebooting the machine, that you can perform upgrades or resets. Finally, Kairos is part of the Cloud Native Computing Foundation. We're one of the sandbox projects. So that means that Kairos is completely open source. You can look into the code. If you don't understand, you can hire someone to look into the code for you so that you understand what it is doing. And that also means that you can drive the development of Kairos if you are interested into doing that. So now let's dive into the architecture. What is happening? How are we trying to solve all those problems that I was previously talking? The first one, it's the immutability of the operating system. Kairos is designed so that the OS, that means components like the kernel, init.rd, we have different versions of Kairos. The most secure one, I will show you later, also has the CMD line for the kernel is also immutable. And you also get, of course, user data where you can write, right? If you, whatever data you're collecting, you can write there, of course. But if someone wants to install a package in your operating system, that is not possible. And this is very useful for many reasons. First of all, you reduce the attack surface of the operating system, because this way, if someone gets a hold of the machine, even if they wanted to install a rootkit or just some package, even if it's not that they are trying to harm you, but you know, we live right now in a world of configuration management. And if someone can SSH into your machine and install packages, all of a sudden you have these snowflakes. But if the OS is immutable, you simply cannot do that. By the way, I have some QR codes there so that you can go into the documentation for the specific feature of Kairos. And please give me feedback. I'm trying to improve on all that documentation. Second thing is Kairos is Linux distribution agnostic. What does that mean? It means that we run on top of OpenSUSE, Alpine, Fedora, Debian, Ubuntu, and Rocky Linux at the moment. But we can also extend it to other distributions. And why do we decide to do that? Well, you already have invested a lot into your operating system. Your engineers already know how to handle Ubuntu or OpenSUSE. And so we don't want you to have to learn a new operating system. Second is licensing. Maybe you are already paying a company like SUSE or Red Hat for your licenses. So we allow you to, what we call is, you take your operating system, you run it through the Kairos factory, and it comes out with all the features that make a Kairos operating system. And finally, it could also be that you have a setup in your company where a certain group creates golden images for you, well, you can also take those and run them through the factory and have Kairos. Another feature that Kairos has is that it can be configured using Cloud Init, which is a common way to configure servers at the moment. And as you can see, it's pretty straightforward. You can define how you create users. If you want to have, for example, Kubernetes set up, you can simply say K3S enabled true. In my opinion, that's as easy as it gets for installing Kubernetes on bare metal, for example. And the default Kairos setup is with K3S, but you can obviously extend it to use other Kubernetes distributions. At the moment, there are like 2 or 3, but the main one, the one that we support, is K3S. We also have a web installer. That means that whenever a machine spins up, you can just go to the URL of that machine in the port 8080 and put the cloud config that you have on the website that is presented and do the installation through that. Of course, this is generally you would do that for one machine, but you wouldn't do it for a group of machines. To simplify also such a case for more machines, what we do is that you can do the configuration via a QR code. So as soon as a Kairos machine spins up, you will be presented with such a QR code, and you can take a picture. And like I was saying, sometimes you don't have an engineer in place. That person can send the picture to the data center or something like that without having to have much technical knowledge. And then the person that is behind the command line can do the setup of that machine just by passing the picture of that QR code. And finally, if you want to set up a group of machines, we have a tool called Aurora Boot. And the way this works is that it's basically net booting. We use Pixie Boot in this case. Aurora Boot will spin up a server. You tell it which of the Kairos flavors you want to deploy on your machines. And then you just turn as many machines as you want within the same network, and they will all start configuring. This is pretty cool, especially if you want to do air gap systems. So let's say that you want to already deliver to your customers 3, 4 machines that become together a Kubernetes cluster. You can do it this way. Another feature that we have is A/B upgrades. The way this works is very similar to how your smartphone works. So we download a completely new image to your system. This becomes like a transition image. And then the active image moves as the passive one. The transition one becomes the active, and the system reboots. If for some reason it cannot reboot, then it will try to go into the passive image, which was just running. So most of the time that should work. But of course, weird scenarios can happen. In that case, we also provide you with a recovery image so that you can go and do all your ninja stuff in the command line, right? And figure out what is broken between the active and the passive images. The recovery one is also very useful because we allow you to completely reset the system. What does that mean? From whatever image that we have in the recovery, so that is the first one that we install, you can reset your system to look again like it was originally set up. One really cool example from a user we have is a teacher in France. He teaches networking, so he gives machines to his students, allows them to do changes in the network configuration, and whether they manage to set it up or they break it, at the end of the day, they can simply go boot into recovery mode and reset the machine completely, and they can use it over and over again without having to have a hassle of setting up the operating system and everything they need to do their classes. Another interesting setup of Kairos is that it's built, the whole thing is built with container images. What does that mean? If you already know how to use a Docker file, you already know a lot of how to create your own Kairos images. We start with these container images, then we take it through the Kairos factory, and we produce bootable artifacts. That could be, for example, an ISO or an image that you can burn into a board like a Raspberry Pi, for example. And this one is going to be used as, in the case of an AMD 64 machine, it's going to be used as an installable media. Then, of course, you install the system, and you can do the upgrade either in the same way, or you can do it with Kubernetes, where it's just like installing any other package with Helm in Kubernetes. You can install an upgrade, basically. Another feature we have is the user data can be encrypted using TPM chips. This is very useful because it's quite harder to tamper TPM chips than it is if it's just software that you're using to encrypt your information. You might say, wait, that's weird. Why don't you encrypt the full OS? Well, the thing is, the OS, there's nothing important on the OS side. So all we have there is what we already provide as open source, so anyone can look at that part. The important part to encrypt is just the user data. And like I said, you can use it with your, if your machine has a TPM chip, you can do it with that. And the nice thing of that is if by any chance someone steals the hard drive from your machine, then they will not be able to unencrypt it if they don't have the machine to unencrypt it. I will show you later too. Well, I think it's, yeah, sorry. We also use the TPM chip to do the measurements of what we call trusted boot. Let me explain what that is. Trusted boot is something that Windows and Mac OS systems have been doing for a while, but unfortunately, Linux hasn't caught up with them. It turns out that while you can do secure boot and encryption on Linux system, this is not enough to keep you safe. If you want to make sure that nobody boots any other OS on that machine, you actually have to be able to measure the artifacts that are going to be booted there. What do we mean by artifacts in this case? Kairos measures the kernel, the init ramfs, the OS release file, and the command line, the kernel command line. That means that nobody can just, even a small change of one letter is going to alter the measurements of any of these, and the system is simply not going to boot. This keeps you safe in a sense that if by any chance someone gets a hold of your machine and installs, and figures out how to install a rootkit, which would be hard again because you have an immutable system. But if they manage to do anything like that, the system will simply not boot if it affects the kernel, the init ramfs, or any of these artifacts. So this is as close as we can get to have a very secure system. Finally, our last interesting feature that I like to show off a little bit, it's the ability to set up clusters with pre-set up peer-to-peer network with self-coordinated clusters. What does that mean? Basically, you just go to the cloud init. You just say that you want to have peer-to-peer. You can decide whether you want certain amount of master nodes and worker nodes, or you can just let the system decide for itself. And all the nodes, as soon as they start spinning up, they start talking to each other, and they decide how they want to be set up. What we use behind the scenes here is another project that we have in our team called HVPN, which basically it's a VPN using blockchain. So Ken, there's a use for blockchain. Maybe not a very famous one, but we ended up finding a tool for it, a use for it. And what happens there? Every node keeps track of the different nodes that it has been able to see, and it will be able to tell if at any point one of the nodes or many of the nodes are, cannot be connected to, then with the information from the blockchain, it will decide, okay, let's reshape the network to look like this. Let's put a different master node, let's put different worker nodes. And this way you can simply start a Kubernetes cluster even in different networks. For example, the way I like to use it myself is I have one of my nodes is on a public cloud so that I can have a public IP, and the rest of the nodes are in my home lab so that I can basically have access to all my home applications going through, in my case, DigitalOcean. Well, and that's pretty much what I had to show you about Kairos. I don't really have a demo because it's an operating system. There isn't much to show. It just spins up and there it is. Actually, we like to say we like it like that. It's a bit boring in that sense because it's just reliable, it's stable. You can trust on it. You can find if you follow that QR code, I think the most exciting thing if you want to see Kairos running is that you install it yourself. If you follow that QR code, you go into our Getting Started guide, where you will install Kairos on a VM, and you will get an idea of how it actually works. Like I said, everything is open source, so this is our main repository. We have plenty of repositories, but that's the main one that you can access. Or you can just download a release and try it out yourself. We have a Slack channel in the CNCF Slack. And we also have office hours on Mondays. Unfortunately, it's European time because, like I said, the whole team is in Europe. But if you're really interested to go, just tell me and we can try to shift the hours for you. And that's it. I don't know if anyone has any questions for me.
Mauro, can I put this slide back up? The previous slide back up?
Yes.
Let me get right away.
Test. Hi,
Hi.
my name's Chad. I was curious if you could maybe speak to some, I've got a few questions actually. Speak to some of the use cases for Kairos. I'd love to hear like, how people are using it in the wild. It kind of helped me to kind of build a mental model around when it makes a lot of sense.
Right. So one of the examples is the one I was sharing about the teacher in France. So an easy way to reset machines if you need it to be. Another case is, like I was saying, for trains, where you want to have a slow cadence of changing hardware, but fast cadence of software updates. Then Kairos itself is, the community is mostly using home labs at the moment, but the company that backs up Kairos, Spectral Cloud, they use it in many different ways. So I don't know specifics that, or more likely I cannot tell you specifics, but it can be used in, I don't know. I think it's used, for example, for military cases and stuff like that, where you might not have access to a good network, for example. One scenario that you can look into, actually, two cases that you can look into on YouTube. We worked together with a company that for farms. They are installing Kubernetes clusters for drones to be able to pick up fruit. And another case it's for dental offices. So they need to process images from teeth, and they just send. I'm not sure. I think it's 2 machines to create a Kubernetes cluster with 2 machines, and all they need to do is just install basically plug the machine in the dental offices, and that's it. Yeah.
So P2P, like detects that the new machine is there, or the device is there, and can grab the data off of it?
Yeah, exactly. Like, I mean, they do the installation of the application because Kairos is just the OS and platform layer, right? So they obviously still install their applications there. They air gap it, and then they send it to their facilities. Yeah.
You got one more?
Yeah.
I'll let you give one more.
So nice to me. Let's see. Oh, so you talked about secure boot. I was curious how that affects upgrades. Like you're doing this checksum checking, I guess, and but you also need to be able to upgrade the OS. So how do the two play nice with each other?
Right. If you're talking about trusted boot, everything starts with your the keys in which you use to sign all your artifacts, and once you have set up your keys, then you just have to make sure that whatever new upgrade you're going to make, you also properly use that key to get all the measurements. This will be recorded in the TPM chip, so whatever new artifact comes, it will know how to compare against that key. And the way we do the upgrades, as I was mentioning, is you download the entire new image. So there is you either have a full system or it simply doesn't upgrade. There is no in between. There is no, oh, it only managed to download a certain number of files, or there's something that got corrupted. You have to have the entire image. If that has been downloaded properly, if it passes the measurements, then it's going to be able to boot this new image. Yeah, that's basically it. I don't know if there's something specific, because there's a lot of detail on how this works, but it's very similar to your phone, basically, where if you already have the new transition image, so to speak, and if it can boot in the system, then that's the one that is going to be running. You're welcome.
Any other question, Joe? Oh, okay.
So my next use case for Kairos is a splitting network where I have a local network of nodes, and then some number of those nodes leaves and comes back. And I have discovered that the re-networking is very difficult under those circumstances. Having the traveling nodes return to the station it doesn't work. Is that a thing that I have to build myself? Is that a thing I'm going to have to do, or does that have any like your story about the drones? Does that have any legs with the Kairos team, or is it am I just shut out of that?
It really depends on the setup, how challenging it can get. In the case that, for example, the Edge VPN can run, which it uses basically the default live peer-to-peer package for Go. So it's not just UTC, but it can also run in multiple types of networks. If that manages to work, that would be the easiest way, I would say. Then it's very likely that the nodes are going to be able to see each other. But it will really depend on what obstacle is really not allowing those nodes to see each other.
Yeah, that's what I don't know.
Yeah.
So under the circumstances, when you separate, totally running networks, and it's kind of magic. What I can't do is continue to make one back out of that. I can't get them to do that.
Well, that's really the nice thing of HPPN, that you will have this extra network that you have no clue why it works. Like, I personally don't understand much how live peer-to-peer works. Sometimes it really looks like magic to me. And that will allow you, for example, like I was explaining with my setup. I mean, it's relatively simple in the sense that I know that I have TCP connection between the public cloud and my home network. But for example, it has happened with some of the cloud providers that because of I don't know, the amount of data that I'm downloading or whatever, they start to close ports to me. And somehow HBPN simply says, yeah, I don't care, then I go through this other way, and it's still connected.
Maybe. Okay.
Hope it helps.
All right, any other questions? Well, okay, I got a small question. So Kairos, would you say it's a successor to K3OS, or made by some of the same team?
Yeah. That's exactly the case. So the guy who started Kairos, Ettore, he was really excited about the Rancher original version of the OS, but since at some point it was killed, the project was, or stopped. I don't know if it's still there, but
it was killed.
It was killed. So yeah. So he continued producing different features for it. Yeah.
Can we give a big round of applause for Mauro Morales? Thank you so much for coming from Belgium to see us.
Thanks, man. Really appreciate it.